It's a common thing that you might quite often need to do in various kinds of scientific computation is to deal with maps or to deal with geographic data that's somehow attached to a map. So in this video we're going to talk a little bit about how to do that sort of thing with Python. And as an example, we're just going to build an annotated map of China. So we need suitable libraries to help us do this. We're basically going to be using this geopandas library, which is a general library for dealing with maps and data attached to maps. And this is built on top of pandas library. The pandas library is a standard thing that you use in Python for various kinds of data analysis. So we're going to see that in a later week, but at the moment we're just going to have a few basic things to do with pandas. Okay, so we're going to start by importing geopandas and also matplotlib, and we're also going to have just a tiny use of these things called regular expressions. So we're going to import a library for those. And one more thing, we're going to annotate our map, and we're going to partly annotate it with Chinese characters. And so we need to be using a font which is capable of dealing with Chinese characters, which is not true of the fonts that you get by default if we don't do something about it. So we're going to have to set the default font for matplotlib using this command here, plt.rcparams font.family equals simsum. This will work on Windows. Probably on other systems you can do a similar thing. So how did I work out how to do that? Again, so there's these. The general message you take home is that there's a huge amount of code. Libraries do all sorts of different things in Python, and you want to work out how to do something. It's quite often effective just to ask one of your AI assistants, such as Google Gemini or something. You just ask Google Gemini, "How do I set the font?" And it will probably tell you. Okay. Okay, so now we need the actual data of the map. Okay, so we need a file which has all the coordinates of the boundary of China and so on. So we can get that from the site called geatom.org. There's lots of sites with all sorts of freely available data about all sorts of different things, which again you can just use a web search or AI assistant to tell you where to find such stuff. So we're going to go to this site. We're going to find map of China. So click on maps is just giving you maps that you can look at. If you want the actual data, you have to click on data here, and then you select the country, and we're going to select China. And so the one we're using is actually a single level 0. Just gives you the boundary of China itself. And we're going to want the version which has the boundaries of the provinces as well. So that's the kind of a level 1 map. So we could download that. I'm not going to download it just now. I'm going to use the copy that I downloaded previously, which is saved on this machine in this directory. So this is a file called chinaprovinces.json. Okay, but actually let's have a quick look at that file. So this is what it is. It's a so-called JSON file. JSON is a standard format for exchanging data sort of between computers or between different programs running on the same computer. So you can see you've got all this kind of stuff with curly brackets, and you've got these things like name and CRS for coordinate system and features and different stuff in with various kind of punctuation, so that the computer knows what to do with it. And then you've got this huge list here of all the coordinates, which is one of the boundaries of some part of the map. But we're not going to deal with that by itself. We're going to use this geopandas thing, geopandas.read file, on this data set. And now this is giving us this object called China. So we can have a quick look at that. So this is kind of all built into pandas. That if you try and you look at an object of this type, then it'll show you a kind of little table. It will show you the data that's in the object in some kind of table form. It might or might not give you. I think in this case, it's actually giving us the whole complete data set because it's not too long. There's only 30 or so entries in the thing. And so here you can see we've got these columns. You've got you go back. If we scroll over to the left again. Okay, so we've got an identifier, and then there's, so here's another sort of code for it, and code for the country and the name of the country, and then there's the basic name here. These are all the names of the provinces, or at least they're mostly provinces. Some of them different things, like Beijing is a municipality rather than a province. Hong Kong is a special administrative region. But mostly they're provinces, like Anhui and Fujian, Gansu, they're all provinces. And you see over here there's the type, the English type. So most of them are provinces, a couple of them are municipalities or other things, and then there's the Chinese equivalent in this column here. And then you kind of got a complete story in most of the columns, but then the last column is the geometry column, and so that's where all the data of the actual points of the outline of the province or whatever are stored, and there's kind of actually a lot of data there that's just you're getting a little snippet of it in that picture. Okay, so so that's what we get by looking at this object. Okay. Okay, so we want to plot a map, and actually, I guess we could just do. We just do China.plot, and it'll plot it for us. But that's kind of without any kind of annotation. It just shows the whole country, and then there's this kind of faint blue lines showing you the boundaries of the individual provinces, and latitude and longitude on the axes. But we're going to want to say like a sort of slightly better map, which has some annotations on it. So we're going to label all the regions with their name in Chinese characters, and so that's kind of mostly be taken from the NL name 1 thing. So so it's again let's so let's just show that that column. Okay, so here we've got all this stuff here, like but we can see there's a couple of issues with it. So firstly, there's a bunch of times there's a kind of bar in the middle, and two kind of similar things on either side. That's because there's kind of two versions of Chinese characters. There's the traditional versions, which are still used in Hong Kong and Taiwan, and the simplified versions that are used in mainland China. So a lot of these names, you've got the traditional version first, and then the simplified version afterwards, after the bar. So one thing we want to do, we're going to take a lot of space on the map if we put both labels in, so we're going to split it up and just use the simplified version. And you see there's a couple of NAs here. Well, this is the kind of basic thing you have to do in any kind of data science type thing. There's always going to end up with some kinds of issues about missing data or something that you might need to patch up. So here there's a couple of things where there's an NA. It's not giving us the name. And if you poke into it a little bit further, you'll find that these are actually Hong Kong and Macau, which are special administrative regions. They have a slightly different legal status in China, and for some reason those ones, they haven't got their names in Chinese characters in this data set, so we have to kind of find those names from somewhere else and just copy them in. And then there's also, we're going to try and put these labels on the map, so you want to have space for them, and some of the labels are rather long, so you might ask why are they so long? I mean, so one thing that happens quite a bit, you've got these three characters here which mean special autonomous region, so they mean autonomous region, and so that's just a bit of noise. So we're going to take out those characters just to shorten the names in some places. And also you can see they've got the same name here repeated several times. This is Yeah, so this is like, well, yeah, this one here is all about Tibet. And it turns out Tibet kind of has three pieces to it that are not kind of connected together. There's the main bit of Tibet, and then there's a couple of little fragments that are sort of, for some reason, they're sort of slightly separate and off to the side a bit and much smaller. So in those cases, we're only going to label the first instance of each. We're going to only have one label for Tibet and not bother labeling the small bits on the other side. And similarly for this one for the Xinjiang. Okay, so those are some modifications we're going to do. So we're going to write some code to do that. So we've got this geopandas thing. We're going to have various columns. We're going to add a couple new columns. So we're going to have a column which is called label, and a column that's going to be called long name. And so the label is going to be this sort of name in Chinese characters, just tidied up a bit, and the long name is going to be something that we're going to maybe use as the title at the top of the plot. Okay, but for the moment we're just just by setting these equal to the empty string, this is just creating new columns for us. So then we need to know where are we going to put these labels. So we go back to here. Okay, so I mean, some of these provinces, some of these provinces have like a nice kind of globular shape, and you just got to put you want to put the label in the middle somewhere. But I mean, here there's like this is Gansu, which is quite bent, and if you sort of naively decide to put a label in the middle of Gansu, then you might end up actually putting it here. And then it wouldn't actually be in Gansu; it would be in the next province over, which I don't remember which one that is. So you need to do something a little bit clever to make sure that the position of your label is actually kind of inside the region you're looking at. But fortunately, geopandas library has a fancy function to do that for us. It's called representative point. So we have to we're going to have to set the label position using this representative point function. And because this is all kind of part of geopandas, you have to do a kind of a slightly funny thing in order to slightly funny syntax in order to make this particular change, which I think I'm not going to explain in great detail in this video. But so you should just be aware that there's something to learn about that. But yeah, we're going to apply this function which takes an x and then finds a representative point and finds the coordinates of it and something. So that's the effect of this line here. So now we're going to go through go through the rows, and we're going to perform various corrections on the rows. And so again, this China thing, it is a pandas data frame. It's a kind of somewhat complicated object. But we can iterate through the rows, but we have to, there's a specific function for it. We do have to call china.iterRows, and that gives us a thing, and we can do for idx, x in there. So x is going to be an object that actually represents the row. Idx is going to be a number that just sort of counts 0, 1, 2, 3. I think we're not actually using idx here. Okay. But yeah, so we've got so perform a few things here. So if the name in the name1 column of this x is Hong Kong, well then we're going to, if you remember there, the Chinese character name is missing, so we'll just set it to this Chinese characters that we can find on the web or something. And the n is going to be the kind of long name for this region. We're going to call it the Hong Kong SAR. And similarly for Macau, we fill in the Chinese characters for that, and set the long name to be the Macau SAR, Special Administrative Region. Okay. So then we're going to deal with this business about traditional or simplified characters. So what we're going to do is we take the name here, which was the NL name 1. That was the name in Chinese characters, but in some but not all cases it had the two versions with a bar in between. So we split along the bar. Okay, and so that'll give us a list of parts where you've a list of parts of the string where you split it at the bars. So if there is a bar, we'll get two pieces, and the first part will be the traditional characters, and the second part will be simplified characters. If there is no bar, then we just get a list of length 1, which contains the whole string. And so we do take the -1 index in that. Remember, the -1 index into a list always gives you the last element. So either way, even if there is a bar or there isn't a bar, this will do the sensible thing. If there is a bar, with this bracket -1 on the end, we're going to get the part after the bar. And if there is no bar, then we get the whole string. Okay. And then, there were these characters here for autonomous regions, so we want to get rid of those. So how do we test if that's right? So we can remember S -3 colon. So that gives us everything sort of from position -3 to the end. So that gives us the last 3 characters of the string. So we test whether the last 3 characters of the string are equal to these 3 characters for autonomous region, and if they are, then we just discard them. So how do we discard them? We just say S is S bracket colon comma -3. That means this syntax here means the substring where we start at the beginning and finish just before character -3. So that has the effect of chopping off the last 3 characters. And then we want to make the long name so to be like a phrase like the province of Gansu, or the city of Beijing, or the Xinjiang Uyghur autonomous region, or something like that. So we got a little bit of logic to set that up. But we also had one extra thing here that we put in the top. So for some reason, the data set that we've got has no spaces between words in some places where you really should have them. So like, for example, there's Ningxua Hui, which really should have a space in between, because that's really sort of 2 words. So what we're going to do is we're going to do a substitution using a regular expression. Regular expressions are kind of very powerful tool for manipulating strings. So we're going to do a rather basic instance of it. So we're going to do as re.sub is substitute in a regular expression, and our regular expression is like this: is A to Z plus in round brackets. So the A to Z plus means a sequence of capital letters, of length at least 1, and then round brackets means that you kind of take that, you sort of group together. You look for such a sequence of capital letters and you group them together and return that as part of your match. Okay, so we're looking for sequence of capital letters, and then we're going to we do a re.sub, so it means you substitute, and so we're substituting with a space followed by \1. So \1 basically means the thing that you matched, so the effect of this is that we look through, and anytime we see a capital letter, we insert a space before it. Okay, so if we did this in Ningxia Hui, then you would get the new string with a space at the beginning and also a space just before the H. You don't really want these. You don't want the extra space at the beginning, but you can do the strip method for strings, which will remove any spaces from the beginning and the end. So the effect of this here is we've inserted spaces between the words. Okay, and then we also maybe down here we're going to add on a phrase like the province of, the city of, etc. Okay. Okay, and remember, we said that there were certain regions where they appear in the table several times. We only want to do one label for them. So because of that, we started off this list called labels here, and we're going to put down here. We're going to take our S, which is going to be the label, and we're going to append that to the list. So now here we're going to test, you see, if S in labels. So if we get to this point, S is in labels, that means that we've already been through this once. This same label has occurred already, and so we don't want to do it again. So what we're going to do is just set S to be the empty string. And then so once we've been through all this, so now the variable S is going to be the label that we're going to use for this particular region, and N is going to be the long name, and so we have to set values in the new columns of our data frame for this S and this N, because these panda data frames are a bit funny, you can't sort of do that in a terribly obvious way. You have to do this china.at_idx. So idx, remember, is the index. That's a number which tells us which row we're at, kind of starting from 0 and increasing by 1 for each row. And then so we have china.at_idx, label is s. That's how we have to set the label for the row numbered idx. Okay, so this will sort out all our labels for us, and we can just check that it worked. Okay, so now we've got labels for all the provinces and all the regions. You see, there's some have been set to the empty string. That's in cases where they repeating things that happened before, and we don't have any blank. Apart from that, we don't have any blanks. We've got strings for Hong Kong and Macau. Okay. Yeah. So then we could just plot that. Okay. So I think I won't go through this, but here we're just going to make a slight adjustment to move a few of the labels to put them in a slightly better position. So now we're going to define a function that displays a particular region of the map. Okay, so we're going to actually let's just show how it works first. Here it is. We have to. Okay, so here's the map, and we've one particular province of Heilongjiang up in the far northeast has been coloured in a different colour, and we've got a title at the top of the map to indicate that, and then all the other provinces and so on are just they have a label somewhere in the middle. And let's do a different one maybe. So now we've highlighted Gansu instead. Okay, so let's just have a quick word through how this works. So we've got region, so we're going to do set R is china.lock, china bracket name 1.str.lower equals region.lower. Okay, so this kind of syntax gives us a sort of sub data set of the original data set. It gives us the subframe of the original frame, but only the rows in which this condition is true. And the condition is that the lowercase name of the region in question is the same as the lowercase version of the name we supplied as the region that we're interested in. Okay, so and then len r tells us the length, how many rows did that match. But we want to be a little bit flexible. So we want to be able to specify the region in several different ways, either given the English name or the Chinese name or whatever. So if we didn't find it the first time around, if it didn't match anything in the name 1 field, then we could look in the var name 1 field and see if that's matched instead. And if we still haven't found it, then we can look in the label field and see if the label, which was just basically the name in Chinese characters, is the same as this region name that we've supplied. And if we get to the end of here, then we haven't found which region it is that we're supposed to be looking for, and so we raise an error. So we get to here, then we do the usual thing to make a matplotlib plot, no axes, and then we're going to set the title. So title, so R, remember, is a kind of sub-data frame consisting of the rows that match the region we're supposed to be looking at. So we look at the R long name, so that's still going to be some kind of fancy data frame. The R long name.values is going to be a list or an array or something, and then you do bracket 0 just to pick out the first one of those. So that'll actually, once we do all that, we actually get a string, and similarly. So that gives us the long name of the region we're looking at, and then here, the same way, we get the name in Chinese characters. Then we plot the whole thing. We say that edge color is going to be dark gray and the face color and the color of the regions is going to be light gray, and we're going to do it on the axis, on this matplotlib axis object that we just put together. But then, so that gives us the whole of China, and then we're going to, on top of that, we're going to plot the specified region. So this R, remember R is a kind of sub-data frame of the China data frame, but it still has the same kind of methods. We can still call a plotting function on it with this. This is a hex code for this kind of light purple color that we were using to annotate the particular region. And so we're going to plot the specified region like that. And then after that, we're going to put text labels on everything. So so we apply this function to everything in every row, and the function, say, given a row X, we annotate the plotting thing with this particular text and the XY position given from the label pos column that we worked out before, and HA is center. That means that whenever you kind of plot a piece of text that picks a point, you have to specify the point at which you say you're plotting it. Is that going to be the sort of bottom left corner of the text, or is it going to be right in the middle of the text, or what? So the HA equals center, that says that the nominal point at which we're plotting the text should be right in the center of the text, because that's basically what that's doing, and so that gives us our show region thing, and we can. So let's maybe Macau, say. You probably can't even see that because Macau's too small. It's down there, so we'll do a different one instead. So we do province of Jilin, again up in the northeast. And that will do for us initial exploration of maps in Python.